when I started out in this work, I was so focused on autism that I really only studied that clinical condition. And I thought, okay, we'll study this. We'll see if there's any dysfunction in the insula that, relates to either the symptoms of autism or that just can be used to discriminate children with a diagnosis from typically developing children. So we did a lot of work on that in, about 10 years ago. And we did find, sure, there's some unique, aspects to insular function and connectivity. And you can even use signals from that region you can apply machine learning algorithms to say, okay, this kid has a diagnosis and this kid doesn't. But I started to realize that because this system is involved in such broad functions that it's likely affected across disorders. So I no longer think it's, specifically this brain area is, implicated in autism. But if you look across studies, there's studies of schizophrenia and frontotemporal dementia and Alzheimer's. They all seem to show some kind of alterations in the salience network. And these are all disorders that come on at different points in the lifespan, involve different kinds of symptom profiles. But when you have a really basic, salience processing deficit, you can see it. You can imagine it's also in anxiety and depression. And so, those kinds of conditions also show salience network abnormalities. So I no longer think that, it's sort of one kind of clinical condition is linked to salience network dysfunction, but it sort of seems to be involved in almost every clinical condition that has been studied at this point.